this representation we introduce our work, Wasserstein Expansible Variational Autoencoder for Discriminative and Generative Continual learning. Continual learning is an important topic in computer vision. It aims to learn a model that can continually capture novel knowledge without forgetting or previously learned information. However, the primary problem for continual learning is network forgetting, which can significantly decrease the model performance when learning a new task. However, most existing methods are only focused on general continual learning, where the task information is always given during training. In this study, we address a challenging task called task-free continual learning, which assumes that the model cannot access any task information during the training. The main difference between the two settings is that task-free continual learning enables the model to be trained on the streaming data without receiving any task labels. There are two problems for continual learning. Firstly, the network usually suffers from forgetting task-free continual learning. Secondly, the existing dynamic expansion model usually creates a large model structure. In order to address those two problems, firstly, we address network forgetting by introducing a novel dynamic expansion model. Secondly, we aim to learn a compact dynamic expansion model by introducing a Wasserstein expansion mechanism. Specifically, we use each VE component to generate a free data sample to represent its previously learned knowledge. Then we compare the distance in the knowledge between the current components and other remaining components. If this distance measure is large enough, the current component has learned enough information, and we should preserve the current component in the mixture system and also building the new components. The whole learning process can be divided into the three steps. Specifically, we present the figure of the two processes, the sample selection and the checking expansion process. In the first step, the sample selection, at a certain training step, we firstly calculate the selection score for each incoming sample by using the average reconstruction error. Then we perform sample selection by using the following equation. In the second step, the training, after the sample selection, we update the current component on the memory buffer by using the loss function. This loss function is mainly used to train the variational autoencoder. In the third step, we check the model expansion. Specifically, we assume that the model has learned k expert at a certain time. We firstly calculate the time series data. Then we check the model expansion by using the following equation, where lambda is this hold, which can control the model expansion process. In the experiments, we firstly evaluate our model on the unsupervised learning, in which we evaluate the log likelihood estimation on the testing data by using the important weighted variational autoencoder lower bound. The results show that our model not only achieves the better results, but also employs fewer components than other baselines. In addition, our model can also be used in the classification task. The results show that our model outperforms other baselines by a large margin. In conclusion, in this paper we propose a Wasserstein Expansible Variational Autoencoder, a new approach for task-free continual learning, which can dynamically expand a variational mixture model. Secondly, a memory buffer is considered for temporarily storing data samples from new database. Data from the memory buffer are selected and used for training according to the novelty detection mechanism in order to further promote the knowledge diversity among components. Finally, the experimental results show that the proposed approach outperforms other methods on the task-free continual learning. Thanks.